Hi, this is Brew. In this video series, we're going to build a 50 amp universal controller. We just recently released the Uniflex, and if you're looking for a 30 amp plug and brew controller with the option for automation, please go ahead and check that out on our website or in the video overview that we posted. This controller, aligned with the universal theme, or Uni, we're going to call UniCon. And UniCon is kind of like a unicorn. Unicorn because it's one of a kind. And there are a lot of controllers out there for home brewers and for professional brewers. And they're all kind of the same. There's a lot of clones. And I think it's time to do something different. It's time to build something that hasn't been used before and can be used to build a brewery in stages, adding automation along the way as you need. So we're going to document this build over the course of 4 or 5 videos. If you have any questions or comments, please feel free to post those with us, and we'll get those answered along the way. Hope you'll enjoy the ride. Thanks. The inspiration for this build will be based upon the controller that was the original test bed for Brew Control, and it's my personal rig controller that is currently used. I've had really good success with this rig, and I think there's some basic concepts that we learned from it, and we'll carry some of those forward and also make some changes that we think will make it better. Let's take a look through it. The right side of this controller contains the power and I/O connectors, and I brought them out through the side to give the ability to mount the controller underneath the brewery. And we're going to do the same for this build. When the connectors come out the bottom, you're really limited to wall mounting for the enclosure only. And one of the nice things about this enclosure is you don't have to have it accessible to the user because all of the controls are done in software on the computer. Now when you look at the bottom row, we can see we have main contactor, circuit breakers for the 2 heating elements, circuit breakers for other accessories. We have additional contactors for accessories and additional circuit protection. We have an SSR bank for the 120 volt devices and the accessories. Above that are a series of terminal strips, and above that are the low voltage devices. We have the power supplies, and in this case we have 3 different voltages. On this build for the UniCon, we're not going to need that. We have an analog amplifier board, a mega interface with a screw shield and Ethernet connectivity, and then behind that is kind of the prototype for the thermistor board, or thermistor filter. And of course we've since formalized that into a plug and play model, but this was the initial prototype. And on the left side are an SSR bank. We have 4 SSRs in a heatsink, 2 for heating elements and 2 for accessories. In this build for the UniCon, we're going to put the SSRs internal to the enclosure. And knowing that the enclosure is large enough, we'll have the ability to sink the heat to the environment very easily and save us from having to punch a big hole in the box. Okay, now that we have figured out the schematic, let's take a look at the enclosure we're going to use. This is a 24-inch square by 8-inch high steel enclosure, and it's obviously very big, but when you're building a control enclosure, especially for automation, you want to have as much space as possible. First of all, the space makes it easier to work, and second of all, the space gives you room for expansion should you choose to do that in the future. Let's take a look inside this big whamma jamma. Okay, so we have a steel backplate, pretty standard fare. This enclosure does not have a gland plate, and that's just as well because we're not going to use it anyway. Because our power and I/O connectors will be on the right side of this enclosure, that side of the back plate will need to be minded on how much free space we'll need to use. So here we have the L630R mounted up against the inside edge, and we can see we'll need to keep at least an inset of 2.5 or 3 inches on the right side of the back plate. As far as the top, left, and bottom are concerned, we have freedom to take our components all the way to the edge. And because we'll be using wire ducting for this, we'll put the wire duct all the way out to the edge on those 3 sides.
Now we'll take a look at the schematic that we're going to use for this build. There are two things you must do when building a control panel. First, you must use a schematic. A schematic gives you the layout of your components, it gives you the wiring, it gives you the safety that you must meet, and gives you a document that you can work off when you're building the panel. Second, and this is maybe more of a should than a must, because in this particular circumstance I'm not going to fully do that, you should draw out the layout for both your panel and your power and I/O connectors. And this ensures that everything will fit as you expect and you won't run into a situation and you have to do any rework. This schematic is built off the universal 30 or 50 amp control panel schematic that we've provided on our website for some time. First, as you look through some of these notes, there are the disclaimers. And I won't read these to you, but it is really important that you take safety seriously, that you determine when you're building one of these that you're meeting the safety standards for your area, that your schematics are correct, that you have professional help, that you meet any building codes or any National Electric Code. We will not accept responsibility for that. We're providing this as information only, and the end product is yours and you're responsible. Keep in mind that you must power anything in brewing by a ground fault circuit interrupt breaker. That is a must, must, must. Anytime you have liquid and electricity in the same area, it's really important that that ground fault is installed and operating correctly. Okay. Now, there's a couple of notes here. If a daisy chain circuit is shown on the schematic, it is just for illustration purposes. You really don't want to wire that way. It's very important for electromagnetic interference that you separate low and high voltage circuitry where you can. Okay? You must use overcurrent devices. They should be within a short distance of the wire length or the power source. Now, in this build, we're not using relay boards because we will use a unishield. But if you were to use relay boards, you need to ensure that they have front end low current circuitry, ideally less than 5 milliamps. And there are certain requirements around those, that they must accept a 5 volt input. Not every relay board like those you find on Amazon or eBay, which will switch, say, a 12 volt or a 24 volt relay, they may not accept a 5 volt input when using an active high configuration. So it's really important that you pick the right brand. We have found that Electronic Salon, that particular brand, will work correctly when switching 5, 12, or 24 volts with a 5 volt input. If you're using an active low configuration, it really doesn't matter. Okay. Now, we're going to build everything into one enclosure. We're going to use RTD sensors. Optionally, this could be built with thermistors or one-wire sensors. The notes are provided here as needed. Now that we have the notes out of the way, let's take a look at the schematic. This particular build will be a 50 amp controller. However, the schematic documents the opportunity to use a 30 amp circuit. The determination of 50 amps or 30 amps is based upon whether you're going to power one element only or two elements at the same time. First, let's look at the high voltage portion of the circuit, and then we'll look at the low voltage portion. The main feed for this control panel will be an L1450P. This is a 50 amp 4-wire plug. That main power comes in through a single contactor. This is a 50 or 60 amp contactor. And as we exit the contactor, we'll feed a series of terminal blocks for line 1, line 2, and neutral. Outside of the terminal blocks, we'll feed a series of circuit protectors. So they are a breaker, 30 amp breakers for both the elements. From those breakers, we'll feed the contactors for the elements, and then the SSRs, and then ultimately the element receptacles. So that gives us our first and second element. And as I mentioned, because this is a 50 amp, we will delete the element select relay shown here. And both of these contactors will be powered at the same time, enabling us to power both elements. As far as the accessories are concerned, we'll use smaller breakers to feed a single dual pole contactor to power our 4 bank of SSRs to power 120 volt accessories such as pumps. Now, because this enclosure will not have any dedicated controls on it, that will not afford us the opportunity to incorporate certain key dedicated controls. And I'm not a fan of dedicated controls. However, there are certain ones that we really must have. They are a key, an e-stop, a power light, and then while we're at it, we're going to add LEDs for the element to show when there's actually power applied to the element. And the way we're doing this in this particular setup is to use a unique enclosure, what we call a user console, to house these controls. So the main control box can be mounted underneath the brewery, on the wall, in a cabinet, somewhere completely out of the way because the user doesn't need to interface with it. But in terms of user interfacing with the physical controls that are not incorporated in Brew Control, they will be in this user console. So the key will turn the control panel on and off, and the e-stop will interrupt power to the high voltage devices. So as long as the key is on, we'll have communication with our microcontroller in Brew Control, and once the e-stop is depressed, we will have, or excuse me, is released, we'll have the ability to power all of our high voltage items. Let's take a look at the low voltage side of this circuit. And you can see first, we have circuit protection for two power supplies, a 24 volt and a 5 volt DC power supply. For this particular build, we're going to use a 24 volt power supply and then a 5 volt DC to DC converter, and that's just for ease of use. We'll have some terminal blocks, and we'll need to account for the total numbers. But we'll have some terminal blocks for the 24 volt, the 5 volt, and ground signals. The main controller in this build will be a UniShield Mega. We're going to use UniShield because it first makes us very easy to wire everything with screw terminals, and second, provides the high current outputs for DC devices directly. So we will not use any relay boards in this particular build. The UniShield will take care of this for us. So for example, if we want to power a solenoid valve as a water fill, we'll be able to do that directly from the UniShield without needing intermediate relays. In this build, as I mentioned, we're going to use RTDs. So we have 4 RTD amplifiers we'll mount in a Brew Control platform. We're going to build in the option for 8, but we'll include 4. So in case the user needs to expand later on, that becomes a viable option. We will include an analog amplifier so that we have 4 analog outputs in case we want to drive proportional valves or other variable output devices. We'll be able to do that directly. And finally, the thing that makes the UniCon universal is the use of a certain I/O connector standard. We'll be using aviation connectors, and each pin on the aviation connector has a certain function. So independent of what connector it is, pin 1 will always be ground. Pin 2 will be 24 volts, pin 3 will be 5 volts, and so on and so forth. And what this provides is a scenario where all of the I/O connectors are installed, and for the user, anytime they want to expand their automation, all they need to do is plug in the right device with the right wiring. They don't have to be concerned about, well, what signal is on what pin, and do I have to change it around and run the risk of mixing pins and mixing connectors and getting it wrong. All they have to do is wire it for that particular device and plug it in, and it will work. And so for this build, we're going to have upwards of 28 standard I/O connectors, 8 analog input connectors, and 4 analog output connectors. And these connectors are shown as just one connector, but we will have multiple in the build. The only reason we're showing one is to ensure that this schematic doesn't get too busy and is not too detailed. Here is a first initial layout, just as a sample that could work for our UniCon. Just like the inspiration build, we have our high voltage contactors and circuit protection along the bottom. To the left of that, we've mounted our SSRs, both for heating elements and for accessories. In the middle row, we're thinking potentially 24 and 5 volt power supplies, terminal blocks for high voltage and low voltage, and above that will be our control system. The larger of these 2 DIN rail carriers is the size of the UniShield. To the right of that, we'll probably put the RTD amplifier platform, and to the left of that, which is not shown, will be the analog amplifier board. So this is just a first idea And in the second part of this build series, we'll actually start the layout, start to mount these components, and initiate the wiring. Thanks for watching. We'll see you again in a few days.